Wolfgang Ernst Pauli, the 25th of April 1900 to the 15th of December 1958, was an Austrian theoretical physicist and one of the pioneers of quantum physics. In 1945, after having been nominated by Albert Einstein, Pauli received the Nobel Prize in Physics for his decisive contribution through his discovery of a new law of nature, the exclusion principle or Pauli principle. The discovery involved spin theory, which is the basis of a theory of the structure of matter. Pauli made many important contributions as a physicist, primarily in the field of quantum mechanics. He seldom published papers, preferring lengthy correspondences with colleagues such as Niels Bohr from the University of Copenhagen in Denmark and Werner Heisenberg, with whom he had close friendships. Many of his ideas and results were never published and appeared only in his letters, which were often copied and circulated by their recipients. In 1921, Pauli worked with Bohr to create the Aufbau principle, which described building up electrons in shells based on the German word for building up, as Bohr was also fluent in German. Pauli proposed in 1924 a new quantum degree of freedom, or quantum number, with two possible values, to resolve inconsistencies between observed molecular spectra and the developing theory of quantum mechanics. He formulated the Pauli exclusion principle, perhaps his most important work, which stated that no two electrons could exist in the same quantum state, identified by four quantum numbers including his new two-valued degree of freedom. The idea of spin originated with Ralph Kronig. A year later, George Uhlenbeck and Samuel Goudsmit identified Pauli's new degree of freedom as electron spin, in which Pauli for a very long time wrongly refused to believe. In 1926, shortly after Heisenberg published the matrix theory of modern quantum mechanics, Pauli used it to derive the observed spectrum of the hydrogen atom. This result was important in securing credibility for Heisenberg's theory. Pauli introduced the 2x2 Pauli matrices as a basis of spin operators, thus solving the non-relativistic theory of spin. This work, including the Pauli equation, is sometimes said to have influenced Paul Dirac in his creation of the Dirac equation for the relativistic electron, though Dirac said that he invented these same matrices himself independently at the time. Dirac invented similar but larger, 4x4, spin matrices for use in his relativistic treatment of fermionic spin. In 1930, Pauli considered the problem of beta decay. In a letter of 4 December to Lise Meitner beginning, "Dear radioactive ladies and gentlemen," he proposed the existence of a hitherto unobserved neutral particle with a small mass, no greater than 1% the mass of a proton, to explain the continuous spectrum of beta decay. In 1934, Enrico Fermi incorporated the particle, which he called a neutrino, little neutral one in Fermi's native Italian, into his theory of beta decay. The neutrino was first confirmed experimentally in 1956 by Frederick Reines and Clyde Cowan, 2.5 years before Pauli's death. On receiving the news, he replied by telegram, "Thanks for message." Everything comes to him who knows how to wait. Pauli. In 1940, Pauli re-derived the spin statistics theorem, a critical result of quantum field theory that states that particles with half-integer spin are fermions, while particles with integer spin are bosons. In 1949, he published a paper on Pauli-Villar's regularization. Regularization is the term for techniques that modify infinite mathematical integrals to make them finite during calculations, so that one can identify whether the intrinsically infinite quantities in the theory, mass, charge, wave function, form a finite and hence calculable set that can be redefined in terms of their experimental values, which criterion is termed renormalization, and which removes infinities from quantum field theories, but also importantly allows the calculation of higher-order corrections in perturbation theory. Pauli made repeated criticisms of the modern synthesis of evolutionary biology, and his contemporary admirers point to modes of epigenetic inheritance as supporting his arguments. Pauli was elected a foreign member of the Royal Society, for MEM-RS, in 1953. In 1958 he became a foreign member of the Royal Netherlands Academy of Arts and Sciences.